And so if you look at this chart here, you can see the weeks of the embryonic period up to week 8. At the end of week 8, this is no longer a developing embryo. We call the developing embryo now a fetus. So the embryonic period is from all the way from conception up until the end of week 8. And if you look down here at the different development organ systems and structures that develop throughout these weeks, you can see why weeks 3 to 8 are considered the period of organogenesis. So this is the period where you can have disruption of embryonic development by teratogens, which is pretty much anything that will affect development. And so that's going to be here between weeks 3 through 8, the period of organogenesis. You can see all of these structures that are developing at this time, and you can see the developing embryo here. After the end of week 8, the embryo is now considered a fetus. And if you look at actual images of photographs of developing embryos, you can see that the embryo's shape really is going to be determined by the organ systems that are developing at that time. Here you can see the somites being very prominent. It makes this embryo appear really unusual, almost alien-like. But actually what's happening is that these pharyngeal arches are developing, and here you have the heart developing. You can see the spinal cord and the vertebral column developing. Here you can see the eye developing. Here's the ear developing, to where the end of the embryonic period, the embryo is now a fetus, and it has a very distinct human appearance. And so the rest of this course is essentially going to be taking these beginning tissues that we laid out today, the ectoderm, the mesoderm, and the endoderm. And it's going to be taking those tissues and developing them through systems to end in the normal human systems that you're learning about also in gross anatomy and in histology. And so one of the things that, or variables and pieces of information that you're going to want to tie together throughout this whole course is what structures are derived from which embryonic germ layers. So you can see here in this long list of everything that comes from ectoderm. You might be tempted to sit down with some flashcards or an Anki deck and Quizlet and go through and memorize that this structure comes from ectoderm and this structure comes from endoderm. But it's really difficult to really hold on to that information with anything besides rote memorization if you start this way. So I want to give you the vote of confidence that this is going to unfold to you as you study embryology and you pay attention to what information is being presented in the questions that we give you. There might be a few things you might want to start thinking about. So for example, in ectoderm, I've highlighted some structures. These structures are the ones you probably want to, they should stand out to you that they come from ectoderm. And the same goes with mesoderm and endoderm. For mesoderm, mesoderm is going to turn into certain tissues that you might want to start thinking about, that comes from mesoderm. And we will reiterate all of these tissues in subsequent lectures, but these highlighted ones you might want to start thinking about coming from mesoderm and endoderm. When you think endoderm, you want to think about these structures here coming from endoderm. And so this will just get you started to pick out some key structures to lay out for you coming from this trilaminar embryonic disc and understand where they're going differentiation-wise. But all of these lectures that we give you and sessions we give you very specifically, you'll know even more detail about what turns into what. Okay, so that's it for me. I'll give you a couple more questions here in your online module. Other than that, I will see you in class and we'll do some fun engagement and integration of the material that we've learned. Thank you.